This is your lesson for Geometry Chapter 9, Section 1. This is Mrs. Norris. We're going to dedicate this lesson to the University of Kentucky Wildcats men's and women's basketball team. It is March Madness around the time that this chapter starts, so we're going to dedicate it to that team. I'm sorry if you're a hater. Anyway, let's get on with the lesson. This is going to look simple at first. This should look very familiar to you. The handout that you have for this lesson shows you three shapes that we've already talked about. We introduced this in Chapter 1. You've seen it in previous math classes, so let's just get right on it. Start filling in our formulas. The formula for a parallelogram is base times height. Looks just like a rectangle, okay? Parallelogram and rectangle are the same. What's the important thing that you should note? You should be drawing an arrow to that perpendicular H. And that's what I want you to write down. You should be expecting either candy or bonus points for remembering the things I'm saying, not just the things I'm writing. Perpendicular height. Same goes with the triangle. We need to remember that we have a perpendicular height. Its formula is 1/2 base times height, or some of you remember it as BH divided by 2. We're going to take the base, multiply it by the height, and divide by 2, which is the same as what this says. Okay, and the last formula is for a trapezoid. Remember, we learned about trapezoids in Chapter 6, I believe. It has two bases that are parallel to each other, remember, and then it has two non-parallel sides. Well, its formula is also involving 1/2. We're going to add the two bases, b sub 1 plus b sub 2. We're going to add those first and then multiply by the height. Okay, I wish that I could say I feel super confident in your guys remembering to write down the formula, but in this chapter it's going to be mandatory, okay? We're not just plotting or writing down numbers real quick. We need to recognize that we're given the area in this problem. So the first thing we're going to do, and these are the little notes off to the side, is we're going to write down the formula for the area of a rectangle, which remember is base times height. The next thing we're going to do, so this is the formula, is we're going to substitute in our given values or what we see in the picture. In this example, you can see in your picture, you can't see it on this screen, but in your picture, that actually 3 is our base. So we're going to put a 3 there. And the area is also given to us, so we're going to put a 27 there. That leaves H as our unknown. In algebra, when we are solving for a variable that's getting multiplied, we're going to divide both sides by 3. And we're going to get H equals 9. And our units for this example are millimeters because our area was given in millimeters squared. Now, you're going to notice, again, I want you to practice underlining, that the actual original problem asked us to find the perimeter for the shape. We need to remember our formulas for our perimeter. So the perimeter of a rectangle is equal to 2 times the base plus 2 times the height. So we had to find the height of our shape in order to find the perimeter. So substituting in the base from the picture, which is 3, and the height, which we calculated, which was 9, gives us a perimeter of 24 millimeters. Another point to note, this is also going to be for candy or for bonus points if you're listening. The units for perimeter, you notice, are what we call linear units. They don't have a square behind them. The units for area have a square behind them. Okay, doing a couple of example problems. Let's start with number 1. Number 1 is fairly simple. The first thing I want you to do is write down, or underline if you will, what they're asking us to find. In this example, they're asking us to find the area. Since it's a parallelogram, we're going to practice by writing the formula. I know this seems tedious for this example because our unknown is the area, but in the next examples you're going to realize how beneficial this can be. The base in the picture is 10, okay? Point number 3 for candy and or bonus points. 10, or the base, is always from vertex to vertex. So it's helpful, especially in certain pictures, if you remember base is from vertex to vertex, and you should remember that height is always perpendicular to the base. So you're looking for that right angle mark there. The height in this picture is 6, so our area is pretty easy to calculate. It's 60. Our units are inches times inches, or inches squared. Again, an area is a square unit. The next one is a rectangle. It wants us to find the base given the area. We're going to write the formula with letters. Then we're going to substitute. Remember, formula, substitution, solution. I'm going to write 136 here because that's what they're telling me A is equivalent to. Put your 36 under the A. Okay, it goes right there. All right, we're going to write 136 there. And since our height in the problem is 8, I'm going to substitute that there. Solving for B, we divide both sides by 8, and we get a base of 17 millimeters. Okay, any of your base or height or perimeter are all just straight linear units. Number 3 is talking about a trapezoid. It's asking us for the area. So we're still going to write it in formula with letters. And we're going to then substitute both bases. In this example, our bases are 11 and 15. And then our height, remember, h is always perpendicular. You can find it simply by looking at this 7 and noticing that it's perpendicular to the base there. So we're going to substitute 7, typing that in on our calculator. Now, always give students trouble which order to do this in. So you have a couple choices here. I always add these two together, 11 plus 15. When I add 11 plus 15, I get 26. So I have 1/2 times 26 times 7. Since these two numbers are even, 26 can be simply divided by 2. So you're going to do 13 times 7 on your calculator, and that gives you an area of 91 meters. Area is squared, so make sure you put your units squared. Okay? I'm going to go back and put a box around all my solutions, and then you can find your answer quickly. Number 4 is asking you for the height of a triangle given the area. You'll notice that they put a 24 here. What is that 24 referring to? The base. Okay, you've got to be able to read your pictures. So we're going to write the area of a triangle formula, which is 1/2 base times height. The area was given to us as 192, so I place that under the A, equals 1/2. The base is 24. My height is what is unknown, so I'm going to call it H. Now, again, we have this times this times this. You do not have to distribute that 1/2. In multiplication, we just multiply the first two things. So we're going to realize since 24 is even, 24 times 1/2 is simple to do in our head. It's just 24 divided by 2. We get 12H equals 192. Dividing both sides by 12, we get a height of 16. Looking back at our units, we see that our units involve centimeters, so our answer is H equals 16 centimeters. Okay, I want you to try number 5 on your own. I'm going to give you a couple hints here. I would write some stuff down. Make sure you don't come in with a blank number 5 tomorrow. This is part of your homework grade. Number 5 is asking you to find the perimeter of a rectangle, given the area, and a height. So you're going to do the exact same thing that we did in the example problem up above. So walk through the example problems. You can even write out notes, step 1 and step 2. Obviously in step 1 you're going to find the base, and in step 2 you're going to plug your height and your base back into the perimeter. We will try number 6 together, and go ahead and flip your paper over now. On the back side you should see your last formulas are 1/2 D1 times D2, and that applies for both a rhombus and a kite. They have the exact same formula. So what does D stand for? D stands for diagonal. Okay, D is diagonal, and you need to be able to find these in your picture. The diagonal is given to you from vertex to vertex. Okay? So make sure you're able to find the diagonal in the picture. All right. Let's go through an example problem quickly here. It's asking you to find D2 when you're given the area. So again, formula with letters. The formula for the area of a kite is 1/2 D1 D2. We're going to substitute 156 inches squared under the A. So formula, substitution, solution. You have to remember that so you can remember to put the 156 on the left-hand side. D1 is given to us in the picture here, if you notice. Let's go over here and look at it. It's given to us as 26 inches, and D2 is not given to us, so it is our variable. Now, the order of operations is not different. We have to multiply those two first, so we get 13. Because it's even, we can just divide 26 by 2. We're going to get 13 D2 equals 156. And finally, we get a diagonal's length of 12 inches when we divide 156 by 13. Don't forget to put your units on there. This is one of the important things from this section. Okay, what I want you to do next is I want you to try only 7 and 8. Number 7 and number 8 are what you should have finished. Number 7 is just a straight, what I call plug and chug. It's asking for the area. So you're still going to write the formula out with letters. I do expect your work on number 8 to look similar to the one we just did, because it's very similar to the one we just did. I will see you guys tomorrow. Go Cats!